Yes, good morning. Good morning, everyone. Good morning, everyone. How are you all? Let me see who all are present in the chat section. Let me see who all are present in the chat section, guys. Good morning. Good morning, everyone. Hello, everyone. Just give me a thumbs up in the chat section. Good morning. Good morning. Good morning. Good morning, everyone. Yes. Yes. Today we will practice a lot of questions of your atomic structure, as well as I will teach you new things as well. All right? Yes. Yes, yes, yes. Definitely I will teach you all today. Okay. Okay. So this is Let's Crack NEET UG English platform. We are going to study atomic structure practice session. This is I welcome you all to Unacademy, India's largest education platform. All right. Yes, I am Nitesh Devnani. I have 5 years of teaching experience, and I have taught over 2000 plus students who have got some great marks in your NEET examination. All right. Yes, this is your English. Let me tell you about the benefits of your subscription plan. Let me tell you benefits about your subscription plan. Yes, first of all, you need to download this Unacademy learning app. All right, just download this Unacademy learning app. Okay, now let me tell you about the subscription plans. There are two types of subscription. First is your plus subscription. All right, in the plus subscription you'll have daily live classes, you'll have live tests and quizzes, there are structured courses, as well as you'll be given unlimited access. You will be given unlimited access in our plus a subscription. All right. Yes. Hello Pulkit, hello Shiny, hello. Yes, in the iconic subscription you will be given a personal coach, you'll have your test analysis, you'll have a study planner also, as well as you'll have all the benefits of plus. Alright, many students need a personal mentor and a personal guide, so that is all available in your iconic subscription. Okay, now see, in the plus subscription you have India's best educators, interactive live classes, structured courses and PDF, and live tests and quizzes. Alright, in the iconic subscription you have all these things, as well as you'll be given a personal coach, you'll have a study planner. Alright, there are experts guidelines also and test analysis also, so that you can analyze which part is your weak and you can work upon it. Alright, all these are in your iconic subscription. Okay. Okay, see, there are free live classes also on your NEET UG platform. There are free live classes. You just need to download the Unacademy learning app. You need to download the Unacademy learning app. All right. Yes, yes. Now see, these are some of the top educators of our platform. Let me tell you about the pricing. Whenever you this was about the iconic subscription. Whenever you are planning to buy the subscription, just apply the code Nitesh. Just apply the code Nitesh YT. Just apply the code Nitesh YT, and you will be given 10% off. You will be given 10% off. All right. Yes, but you need to apply the code Nitesh YT. All right. Now see, 6-month course will be getting at 34,200 rupees, 12-month course will be getting at 58,500 rupees, and 24-month course will be getting at 90,000 rupees. All right. Now let me tell you about the plus subscription. Again, you need to apply the code Nitesh. Nitesh is my name, Nitesh YT. All right. You will be given off. If you are in 12th standard or if you are a dropper, I would recommend you to go for 12-month course. Alright, 12-month course would be at 34,650 rupees, and 24-month course will be at 50,400 rupees. Alright, if you are in 11th standard, you can go for 12-month course also. Just apply the code Nitesh YT. You will be given 10% off. This is the maximum of you which you can get, and you will be also benefited. I will be also benefited whenever you apply this code Nitesh YT. Alright. Yes, these are some of the benefits of your Plus subscription: daily live classes, live test and quizzes, structured courses in PDF, and unlimited access also. Yes. All right. So let me see who all are present. Just give me a thumbs up. Just give me a thumbs up in the chat section. Good morning, Rahul. Good morning, Shiny. Good morning, Pulkit. Just give me a thumbs up in the chat section. Let me see who all are present. We'll practice questions also, as well as I'll teach you different new things also. Okay. Good morning, Nishtha. Good morning, Shiny. Good morning. All right. Good morning, Rahul. Yes. Good morning, Supriya. How are you all? How are you all, guys? Yes. Good morning, Keshav. All right. All right. Yes. Okay. Now see, before practicing some questions, let me teach you how to write. Let me teach you how to write electronic configuration, and we'll practice questions then. All right. How to write electronic configuration. How to write electronic configuration. All right. Let me teach you this thing. Yes. See, there are certain rules if you want to write electronic configuration. There are certain rules which we need to follow. First rule is Avbhav rule. Alright, Avbhav is the name of a scientist. Alright, Avbhav rule. What does this rule says? What does this rule says? Good morning, Sajjan. Good morning. Yes. What does this rule says? According to this according to this rule, electrons are filled in increasing according to this rule, electrons are filled in increasing order of energy of orbitals. Correct? How to find the energy of orbitals we have studied in previous classes. How to find? If it is a single electron species, energy depends on n. If it is a multi-electron species, energy depends on n plus l. So what was the order? 1s has lowest energy, then 2s, then 2p, then 3s, 3p, 4s, 3d. Correct? This was the sequence. Tell me in the chat section. So left to right as we are going, energy is what? Increasing. Alright, and we need to fill in increasing order of energy only. So first 1s would be filled, then 2s, then 2p. Alright, this thing I've explained you about the energy thing in our previous class. Tell me in the chat section, guys. I've explained this, right? Yes. Alright. Yes. Good morning, Swasta. Yes. Alright, great. Second rule is, let me explain you second rule. Second rule is Pauli's exclusion principle. Pauli's exclusion principle. Pauli's exclusion principle. Let me give you what does this this principle says. No two electrons can have same value for all four quantum numbers. No two electrons can have same value for all four quantum numbers. Alright, I will explain you this. I will explain you when I will write electronic configuration. Let me first write all the rules. Last rule is Hund's rule of maximum multiplicity. Hund's rule of maximum multiplicity. Alright, what does this rule says? This rule says pairing of electron is done. I will explain you each and everything, don't worry. Pairing of electron is done only when each orbital contains at least one electron with the same spin. Alright, yes, so these are the rules. Alright, now I will explain you with the help of your electronic configuration. I'll write down electronic configuration one by one. Alright, okay, let us start with hydrogen. Alright, hydrogen has Z equals to 1. Alright, and it has only one electron. Correct? Now see, which orbital would be filled first? 1s, increasing order of energy, na? And tell me in the chat section, S subshell has how many orbitals? S subshell has how many orbitals? Has how many orbitals? One orbital, correct? So it has one orbital. This is your 1s, and one electron would be filled. One electron is filled. Alright, so this is what 1s1. Alright, then it is your helium. Alright, He. Your Z equals to 2, means 2 electron you need to fill. So one more electron can be accommodated in 1s, na? One orbital can accommodate maximum 2 electrons. So this way your 1s can accommodate 1 electron, but its spin would be opposite. Their spin should be what? Opposite. So this is what? 1s2. Are you getting my point? Now tell me. Now it is your lithium. Z equals to 3, means 3 electron. Can we add more electrons in 1s? No. Why? Because 1s only has your one orbital. One orbital means maximum 2 electrons. Alright. Now the next orbital which would be filled is your 2s. So this means it is 1s2, 2s1. Alright. If I draw 2s here, this is your 2s. Correct? Now fourth is your beryllium. 4 electron we have to fill. So it would be 1s2, 2s2. Got it? Is this correct? Yes, it is correct. Very, very good. Alright. Now you have your fifth as your boron. Boron means 5 electrons you need to fill. Alright. Now see, 2s is completely filled. Maximum number of electrons which can accommodate in 2s is 2. So 2s is completely filled. Now what is the next orbital? Just look at here. Next orbital is 2p. Yes, okay. So this would be 1s2, 2s2, 2p1. This is your p. Correct? This is your p. One electron. Correct? Now your carbon. Carbon means 6 electron. 1s2, 2s2. We can add electrons in p. Correct? 2p2. Now see. Now just pay attention here. According to this rule, Hund's rule of maximum multiplicity, pairing of electron is done only when each orbital contains at least one electron with the same spin. Means if you try, this was your boron configuration, and if you try to put one electron here only, you are doing pairing. So this is wrong. Alright, what is correct is? Correct is your this. You have your 3 orbitals. First fill all the orbitals with the electrons. Of same spin. This is correct. Are you getting my point? This, see, suppose this is your 7, this is your nitrogen, 7 electrons, 1s2, 2s2, 2p3, correct? Now 2p3 means first all the orbitals would have one electron of same spin. This is correct. Are you getting my point? Tell me in the chat section. Are you all getting my point? Now suppose now 8th is your oxygen, 8 electrons. Now tell me, can we add more electrons in 2p? Can we add more electrons in 2p? Tell me in the chat section. Can we add more electrons in 2p? Yes, we can add now. Now see, because see, 2p has 3 orbitals means your 6 electrons, maximum 6 electrons. I've explained this, correct? So this means 1s2, 2s2, 2p4. Now 2p4, now see, your each orbital would have a 1 electron. Now pairing would be done. Now one more electron you need to add. Now pairing would be done. This would be your pairing. Alright, are you getting my point? Alright, now see, 9th is your fluorine. Fluorine is 9 electrons. This is 1s2, 2s2, 2p5. If I try to draw 2p5, it is like this. First each orbital would contain 1 electron of same spin, then we will do pairing, correct? 10 is your neon, then your 10 electrons means 1s2, 2s2, 2p6. Got it? 2p6 means like this. First each orbital would have 1 electron, then we will have pairing, correct? Is this clear? Give me a thumbs up in the chat section if this is clear. Yes, from our this is one of the last classes of this chapter, Amisha. Yes, perfect. Yes, yes. Now you can write off sodium, magnesium, aluminium. You can write all these things. All right. Now I am going to tell you electronic configuration of the elements which are important to us. They are very important to us. All right. Let me tell you. See, let's write it of 19. First, let's write it of 19. 19 is potassium. 19 electrons. How do we write it? 1s2, 2s2, 2p6. After 2p you have your 3s and 3p, correct? Then it would be, you will have 3s2, please wait, yeah, 3s2, 3p6, 4s1. all right, this is your potassium electronic configuration. All right, now see, we can write electronic configuration in condensed form also. Tell me how many electrons up till here. Up till 3p6. Tell me. Just add these, na? Just add these. This is 18 electrons. 18 means your element is argon. So we can write it down as argon 4s1. Means you can always take a nearest noble gas. Correct? Now see, 20 is your calcium. 20 electrons. What we can do? We can write it at argon. Means you have filled 18 electrons, and this will be 4s2. This would be 4s2. Got it? Just pay attention here. There is one important thing, that see, 4s is filled before 3d. Why? Because n plus l rule. We have seen n plus l rule. 4s is filled before your 3d. All right? Yes. Now see, you have your 4s completely filled. 2 electrons, we can write 2 electrons only. That is completely filled. Next is your 21. Now these are important. 21 is scandium. Z equals to 21. means 21 electrons you need to fill. Argon, this means you have filled 18 electrons. 4s2, 20 electrons. 3d1. 3d1 means your d subshell means how many orbital? 5 orbitals. And here it is your 1 electron. Alright. 22. Titanium. Titanium means your 22 electrons. It would be argon 4s2 3d2. Now tell me, will we do pairing here? Will we pair this electron? Tell me in the chat section, will we pair this electron? No. First, each orbital would contain one electron of same spin. So 3d is like this. 3d is like this. Yes, very good. Similarly, next is your vanadium. Vanadium means 23 electrons, argon 18, 4s2 3d3. Correct? 4s2 3d3. Now 24th is chromium. This is an exception. Electronic configuration, you need to fill 24 electrons. Electronic configuration is argon 4s1 3d5. 4s1 3d5. Yes, it was, see, after vanadium it was supposed to be 3d4, right? Chromium was supposed to be 3d4, but electronic configuration is 4s1 3d5. How? Just pay attention here. This is your 4s and your 3d is this. I will explain you what is the reason for this. I will explain you in a bit, but just first understand this. Chromium is your exception. All right. 24 electrons and electronic configuration is 4s1 3d5. all right, I will explain you what is the reason behind it. I will explain you. Okay, let us move forward. Next is your manganese. 25 electrons. Electronic configuration argon 4s2 3d5. all right, yes. Next is your iron. 26 electron, argon 4s2 3d6. See, in d subshell you have your 5 orbitals, correct? You have your 5 orbitals. In the 5 orbitals, maximum you can have 10 electrons. Correct? So 3d6 is correct. Now let me draw 3d6 for you all. What is the criteria? First, fill each orbital with 1 electron. Correct? 5 electrons are being filled. Then the 6th electron will do pairing here. Simply pairing here. Alright. Okay. Great. Now see. 27 is your. Up till now, any doubt? Do you guys have any doubt up till now? You can ask me. You guys can ask me if you have any doubt up till now. No? Alright. Alright, Sasda. Alright, Kavitha. Great. Now see, 27 electrons. Again, the electronic configuration would be argon 4s2 3d7. 28 is your nickel. 28 electrons, argon 4s2 3d8. Correct? 29th is your copper, and this is your second exception. 29 electrons you need to fill. Alright. What according to your rules? It should be what? 3d9. Simply just increase 1 electron in d na. But electronic configuration is 4s1 3d10. Alright. This is your 4s and 3d is like this. First fill all the orbitals with 1 electron, and then you have your pairing. This is 3D. All right. Again, this is your exceptional behavior. I will explain you why the reason. What is the reason? I will explain you. Just please wait. Yes. All right. Yes. And last is your zinc. 30 electrons means your argon 4 is to 3D 10. Okay. Okay. Now just pay attention here. You have your two exceptions. First was your chromium, and then second was your copper. Yes. Now, reason for uh, exceptional behavior of chromium and copper. Why this is exceptional behavior? ठीक है? All right. Okay. For chromium, first is for chromium. It is stable. Due to half filled stability of d orbitals. Okay, let us see the electronic configuration of chromium. See, this is your d orbital, this is your 3. Is it half filled? Yes, because maximum electrons you can fill 10 electrons in d, and you have filled 5. 1 1 1 1 1. All right, so this is a very stable configuration. If you have any half filled stability, all right, if you have any half filled orbital, that is very stable. Now why it is stable, I will again explain you. We need to know why it is stable. We have understood that it is stable, half filled is stable. Now why it is stable, I will just explain you. See, now for copper, it is stable due to fully filled stability of d orbitals. Just pay attention here. See, this is your copper, this is 3d10, means maximum electrons you have filled. Your d subshell is very much packed. All right, so this is also very stable. Full filled and half filled orbitals are very stable. Now the question is reason for half filled and fully filled stability. All right, what is the reason for your half filled and fully filled stability? What is the reason? First reason is symmetrical distribution of electrons. All right, right? See, here you're in this d10, all the d orbitals have 2 electrons, so there is a symmetry, correct? In your d5, this d5, all your orbitals have 1 electrons, all right? So this is again what, very symmetrical. Happy birthday, Rajveer, happy birthday. Yes, my blessings are with you. Yes, great. Yes, all right. So again, d5 is what, very stable. D5 is very stable. Why? Because this has symmetrical distribution. Okay. Yes. Another reason is exchange energy. Now what is exchange energy? This is your d5. I'm 3d5. All right. Now what happens is your electrons exchange these positions. All right, electrons exchange these positions. All right, in itself only electrons keep on exchanging these positions. Now tell me, you guys need to tell me, if electrons would exchange positions, they will emit radiations. More the number of exchanges, more is the energy emitted. More is the energy emitted. Correct? Correct? More the number of exchanges, on exchanging energy is released. So if there are more number of exchanges, more energy would be released. Now tell me, if more energy is released from the system, stability would increase. Yes, stability means less energy. Stability means less energy. Therefore, stability increases. Yes, stability would increase. Is this point clear? Tell me in the chat section, is this point clear? Is this point clear? Tell me in the chat section, guys. Great Kavi Priya, great Shiny, yes, yes. Great Rahul. Great Keshav. Yes, Nishta. See. Because of this half filled and fully filled orbitals, this is your fully filled orbital. All right. The electrons. What does electrons do? Electron are simply. Let me draw first D10. Electron are simply what? They are exchanging positions with each other. They are exchanging this position with each other. They are exchanging position with each other, and while exchanges, they are emitting radiations. They are emitting energy. All right. Now see, if they are emitting energy, more the number of exchanges, more is the energy emitted. More the number of exchanges, more is the energy emitted. Yes, and if more is the energy emitted, the system would have lesser energy. Lesser energy means higher stability. All right. Now is it clear? Now is it clear? Any doubt, guys? Any doubt up till now? Any doubt up till now? All clear. Great. 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 All right. All right. Now see. Now there is one more term. There is one more term which we need to learn. That is magnetic moment. Magnetic moment. You write it as mu. You write it as mu. Magnetic moment. The formula is n into n plus 2 under root Bm. What is Bm? Bm is Bohr magneton. It is its unit. Bohr magneton is what? Unit. Bm is what? Just a unit. Alright. Now what is this n? This n means number of unpaired electron. N means number of unpaired electrons. Alright. Now see. Now I will ask you questions and you need to answer it. Now I will ask you questions. Alright. I will start asking you questions. Find magnetic moment. Find magnetic moment. Alright. What is the formula? N into n plus 2 under root. This is the formula. Where n is what? Number of unpaired electrons. Alright. Alright. First is manganese. And second is your chromium. Alright. Let me see. You guys try this. Then I will explain you. Don't worry, I will explain you. First, you guys try it. You don't need to solve this root thing. Just give me your answer in what? In a root only. Then we'll practice some questions. All right. Yes, first write electronic configuration of manganese. Manganese means how many electrons? 25 electrons. Alright, so see, this is argon, 4s2, 3d5. So see, up till argon everything would be paired. 4s2, 4s2 means this. 4s2 is this. This is paired, na? This is paired. 3d5. 3d5 is your like this. 3d5 is like this. Correct? So it has how many unpaired electrons? This has 5 unpaired electrons. N is 5. Formula is 5 into 5 plus 2 under root Bohr magnet. Yes. Alright. Now try for chromium. Tell me answer for chromium. Try for chromium. You need to write electronic configuration of chromium. Yes. Yes. It is what? 24 electrons. Electronic configuration, this is an exceptional behavior. It is 4s1, 3d5. So this is your 1 electron and this is your 3d5. This is your 3d5. Correct? Yes. So it has what? N equals to 6. Formula is 6 into 6 plus 2 under root Bohr magnetum. So 6 into 8, root 48 bm. Yes. Very good. Now again you need to find a magnetic moment also. Anyone has any doubt up till now? You guys can ask me. Anyone has any doubt up till now? Any doubt? Okay, great. Now the third, again you need to find magnetic moment only of manganese plus 2 and then of manganese plus 4. Alright, let me see. Yes, I will show you after this example, Kunal. I will show you. Manganese plus 2 and manganese plus 4. Now there are ions. Now these are ions. Yes. Come on, everyone. Now these are ions. Now just pay attention here. I will explain you this. Third option is your manganese plus 2. Alright. First, please pay attention here. First, write electronic configuration of manganese. Simply write first electronic configuration of manganese. This is what? Argon 4s to 3d5. 4s to 3d5. Please pay attention here. Please pay attention here. Yes. Now see. Now you have to write electronic configuration of +2. Now you need to take 2 electrons. The question is whether you want to take 2 electrons from 4s or 3d. Tell me in the chat section. Tell me in the chat section, from where will you remove electrons? From 4s or 3d? From where will you remove electrons? Tell me in the chat section. Okay. Okay. Now let me explain you this. This is your nucleus. Alright, this is your nucleus. Please pay attention here. This is your nucleus. This is your first shell. This is your second shell. This is your third shell. And this is your fourth shell. Alright, this is third. This is fourth. Now 3D is present in which shell? Third shell. This is, here it is your 3D. 4s is present in which shell? 4s. Here it is your 4s. Now electrons are always removed from outermost shells. Electrons are always removed from outermost shells. So electrons are first removed from 4s. Yes. Electrons are first removed from 4s. Why? Because it is outer. So 2 electrons you need to remove. The electronic configuration would be argon 3d5 4s0. Are you getting my point? Now see, d5, you know how to draw d5. This is your d5. Number of unpaired electron is 5. Now Bohr magneton, 5 your magnetic moment, under root 35. So always remember, electrons are first removed from 4s. Why? Because it is an outermost shell. Is this thing clear now? Is this thing clear? Alright, now you guys attempt for manganese +4. Now you guys attempt for manganese +4. Now you guys attempt manganese +4. You guys attempt now this question. Alright. Yes. First I will, this is the procedure you need to follow. First write of manganese. Always first write with the neutral atom and then proceed towards iron. This was the electronic configuration. Now manganese +4, you need to remove 4 electrons. 4 electrons means first you will remove electrons from here. Alright. Then you need to remove 2 more electrons. Then electrons would be removed from 3D. Yes. So argon, it would be 3d3 4s0. Yes. 3d3 means your 1, 2, your 3, n is your 3 into 5 under root. So this is root 15 Bohr magneton. Very good. Very good. Now can you write electronic configuration of ions? Now you guys can write electronic configuration of ions. Correct? Correct? Yes. Very good. Now there is a one more concept. There is a one more concept of nodes. Alright. What are nodes? Nodes are region of space where probability of finding an electron is 0. That means you can never find an electron on a node. You can never find an electron, means psi square is 0. Do you guys remember psi square? We used to write a psi square for probability. Do you guys remember it? Right? Yes, yes. Now see, there are your nodes are of many types. First is your radial nodes. And we just need to understand the formula of it. Radial node formula is n minus l minus 1. All right. Some nodes are angular nodes. Formula is simply L, azimuthal quantum number. Radial node means it is circular in shape. Angular nodes means it is at some angle. Alright? And third is your total nodes. Just add these two. L and L would cancel. Formula is n minus 1. Okay. Just a formula you need to remember, nothing else, nothing more. All right. Suppose you have your 3p. Tell me how many radial nodes and angular nodes. Rn is radial nodes, An is angular nodes. Rn is radial node, An is angular nodes. Tell me for 3p. Yes. Apply the formula. For radial node you have n minus l minus 1. For angular you have your l. Just apply the formula. This is your n. This is your l. Alright, l is what? 1 here. So 3 minus 1 minus 1, which is 1. And angular node simply l. L means 1. Correct? Yes. Alright. Yes. Very good, Shiny, Rahul, Nishtha, Supriya, great, Kavipriya. Very good, Keshav, Kunal, fantastic. Yes. So Kunal, you were asking about that reason part. You guys can take a screenshot of this if you guys want. Yes. Alright. Great, Kavipriya. Yes. So this was all about your atomic structure. We have covered each and everything in detail, and we have practiced questions. Now you guys need to practice more and more questions. And if you guys will tell me, we will take one more practice session. Do you guys need practice session for this? Do you guys need a practice session for this? Tell me in the chat section. Do you guys need practice session? Yes? Okay. We'll have practice session also. We'll have a practice session, don't worry. We'll have practice session of atomic structure. Alright? Yes. Now we will take a periodic table. Next chapter which we are going to take is periodic table. Alright, very small chapter. In 2-3 days we will complete it, and then we will move on to our very important chapter of chemical bonding. Very important chapter. Okay? Alright, so I will meet you in the next class. Okay, take care guys, have a great day, and practice lots of questions. Okay, practice lots of questions. Okay, great Kavipriya. Next chapter we will be taking is as a periodic table. Alright, because that is an important chapter, because from that chapter only you will be able to understand chemical bonding. Okay, great. Take care, guys. Bye bye. Have a great day and start practicing questions, and like this video if you are able to understand everything. Like this video if you are able to understand everything. Okay, and share with your friends. Obviously, you have to share with your friends. Okay, bye bye, guys. Take care.